Hello, students. Before I start talking to you about section 1.6, I have to review an old idea, and that idea is domain restrictions. Now, we have a couple things in our real number system that we're not allowed to do. First of all, when you have a fraction, the bottom of it cannot be 0. That's very bad, so don't do that. And we're going to pick x's so that we don't get zeros in the bottom. Another thing, when you have a radical, you're not allowed to have a negative underneath a radical with an even index. That's also very bad. And we're going to choose our x's so that we can avoid those things. Now, I want to point out that there are only 2 domain restrictions that we've talked about so far. We'll get a couple others later. We're going to get over to logarithms, but right now we only have 2 domain restrictions. So we only have 2 things to watch out for. It's mostly vocabulary. Domain restriction scares people, but that's okay. So we only have 2 little tiny things to worry about. So, first of all, my problem number 2 in the homework. I have 1 over x minus 4. This is problem number 2. And plus 1 over x plus 3 is equal to 1 over x squared minus x minus 12. So let's talk domain restrictions. I cannot allow my x to be something that would enable me to have a 0 in the denominator. So before we even get started with solving this problem, and at this point they're not asking you to solve, they just want you to take a look at it and get some information. We have to identify what things x is not allowed to be. For example, right there, x cannot be a 4. So if x is 4, then we have a domain restriction. We have a 0 in the denominator. That's a domain restriction. We're not allowed to say that x is 4. Also, because of this one, we're not allowed to say that x is equal to negative 3. So I have to exclude from my possible answers a 4 and a negative 3. Those 2 things are going to be bad. Now this one over here, this is made up of x minus 4 times x plus 3. So I've already talked about I'm not allowed to have a 4, so that one's already taken care of, and I'm not allowed to have a negative 3. So that one's also taken care of. So I say that my domain restrictions, or the way that they say it in here, is the values of x that cannot be solutions of the equation are going to be negative 3 and 4. Now we've talked about domain restrictions already, and in your homework you're required to identify domain restrictions when you're dealing with rational equations. That means the one with fractions in them. But you are not required to deal with the domain restrictions in separate problems when you have radical equations. Those are the ones with the square roots in them. So they'll ask you in the equations with fractions which domain restrictions, or what other domain restrictions, what are you not allowed to use. But with radicals, then you don't get separate questions, and you just have to solve and then check your domain restrictions when you're done. And we'll talk about that more when we get there. So first of all, we have 3 kinds of equations that we're going to be solving in this section. The first kind is rational. And when you see rational, I want you to remember the word ratio, because that is going to be the fraction section. So that's the one with the fractions in it, and that means that we're going to be clearing our fractions, review how to clear fractions, and we're going to be using the LCD in order to clear them, and then we'll check the domain restrictions against that LCD. The second kind is the radicals. We're mainly going to be focusing on the square root, but the equations with radicals in them. And we're going to talk about how to solve a radical when there's one radical and how we need to isolate. And then we're going to also talk about how to solve when there are 2 radicals. And then the third kind of equation is the kind of equation that is of a quadratic form. In other words, you're looking for some sort of setup where you have an x to the 2n plus some sort of b x to the n, and then plus a c is equal to 0. Now, what that means is that it's going to be kind of like a quadratic. We're used to having something with a squared term and our quadratic term, our linear term, and a constant term. But what we're going to have here is something where we don't have something quadratic, but we might have the right ratio of exponents. For example, this might be a 4 and this may be a 2, and that one's still going to be constant. But I still have the right ratio. This exponent must be double this one, or I might have a negative 2/3 and a negative 1/3, and this one's a constant term. That's going to be something that we can pretend that it is a quadratic, even though it's not really quadratic, and it's going to be something that's called a quadratic form. So the first equation that we're going to solve is a rational equation. You see, it's a rational equation because it has ratios, it has fractions in it. The very first thing we want to do is identify our LCD, our least common denominator. In this case, it's going to be x squared, because everything needs to be accounted for here. So we have the x squared, which is here, have an x, that's a factor of this, and this denominator is a 1, which is a factor of x squared. So the least common denominator is an x squared. That's also going to give us a hint about what our domain restrictions are, because our domain restrictions and our LCD are both based in the denominators. So our LCD needs to be set equal to 0. That means that our domain restriction is 0. In other words, x can be any real number other than 0, so we're going to find out which one it is, but if we get a 0, we have to exclude it. Now, I'm going to multiply these three terms by my LCD, and when I do, then I'm going to end up with my numerator times whatever my denominator was missing from the LCD. This first one was missing nothing, so I'm not going to multiply by anything. So the 53, I have an x, but my LCD is x squared, so I still need one more x. It was missing one of the x's, and that's equal to 18, and my denominator was missing all of my LCD, so I need to multiply that by x squared. So this is now going to be my quadratic term, and I like to move everything to where my quadratic term is positive, which means that my linear term and my constant term need to go to the right-hand side. So 0 is equal to 18x squared plus 53x minus 3. Did that because we were switching sides. Now we need to factor this. So 0 is equal to, now we can set up some factors, but we only have a couple options. Let me show you one of them. And this one is not going to work. See how I have an 18 over here and a 3 over here? I know that I can't get factors of 3 in the same set of parentheses. So that means that I couldn't do, let's say, a 6 and a 3 to make the 18, because then I would have nowhere to put the 3 factor from here. So I need to shuffle all of my multiples of 3 in one section. So it may be 9, and then I'd have a 2x left over, so I'd have a place to put my 3, and then I must put a 1 there. That's all that's left. So I have 9x and 1 in my first set, and 2x and 3 in my second set. And our goal is to see if we can get a difference of 53. This is 27, and this is 2. That is not our set of factors. But I didn't really have too many options. Let's show another one. So 0 is equal to 18x. I know that I can't move any of these factors over here because I'm not gonna have a place for my 3. So 18x and the 3, and this is just gonna have to be an x and a 1. Now let's check. Now I have a 54 if I multiply these outer terms, and then I have a 1x if I multiply the inner terms. So if I choose this one to be positive and this one to be negative, then I can get a positive 53x as my middle term in that quadratic. Now that means that this is set equal to 0, and then this is going to be set equal to 0 also. When this is set equal to 0, I add 1 and divide by 18, so x is equal to 1 over 18. Over here, when this is set equal to 0, then x is equal to negative 3. So these are my two answers. Now remember that we have to check against our domain restrictions. Our domain restriction was 0. Neither one of these are 0, so we're allowed to use both of them in our solutions. Now another rational function. First of all, let's identify the LCD in my problem number 8. So the LCD is going to be x times x minus 2. So the x minus 2 is covered here, the x is covered here, and this one is a product of these two. So, so this LCD covers every single thing that we have. Now, our domain restriction, since we're here to identify it, this can't be equal to 0, so I can't have 0, and this one can't be equal to 0, so I can't have a positive 2. Those are my domain restrictions. That means when I'm done with my problem, I need to make sure that none of my answers are either 0 or 2, and if they are, then I have to exclude them. So the next thing is to multiply my numerators by whatever my denominator was missing. This had the x minus 2, so I need to multiply it by an x, plus 2 times, it has an x, so I'm going to multiply it by x minus 2, and that's equal to negative 4, and I don't need to multiply it by anything because that denominator is the product of the two factors in my LCD. So now I need to use the distributive property. So 7x squared plus x plus 2x minus 4 is equal to negative 4. Now I need to combine like terms, add 4 to both sides, and add x and 2x. So then 7x squared plus 3x is equal to 0. Now I know that I have to set it equal to 0 because it's quadratic. Had it been linear, we would have just solved without setting it equal to 0. But since it's quadratic, we know we have to set it equal to 0 and then factor. Now, the only thing that I could factor is an x. So I have x times 7x plus 3 is equal to 0. Now, both of these have to be set equal to 0. X is set equal to 0, and then when this one's set equal to 0, then I get negative 3 over 7. Now, I go back and I look at my domain restrictions. I'm not allowed to use 0, and I'm not allowed to use 2. But one of my solutions was one of my domain restrictions, which means I'm not allowed to use that. Because if x happens to be 0, then I'm going to have an undefined, and we definitely do not want an undefined. So I have to exclude that, which means that my only answer, my only solution, is negative 3 over 7. Now let's talk about solving an equation with a radical. This one has a radical in it. There's the radical right there. That's square root simple. Now, the first thing you need to do is isolate your radical. Luckily, number 15 from my homework is isolated already. So the square root of 5x plus 99 doesn't have anything on that side except for that chunk, that radical chunk right there. So when I have something like a radical isolate is equal to other stuff, then I'm going to square both sides because that makes the radical disappear. And when I square both sides over here, then I'm going to have a perfect square trinomial. This one just stays 5x plus 99, and that's equal to, and remember how we square a perfect square trinomial, we have the first term squared, that's 4x squared. Leave some room, 22 squared would be 484. And then to get your middle term, you multiply these two together, you get 44, and then double that, so 88. So plus 88x. So I have 5x plus 99 is equal to 4x squared plus 88x plus 484. Now this thing's quadratic. You can see right here I have an x squared term, which means it's quadratic. That tells us that we need to set it equal to 0. Now my quadratic will have a positive coefficient on the right hand side, so let's move everything over to the right hand side. I'm going to subtract 5x from my other linear term, and I'm going to subtract the 99 from my constant term. So 0 is equal to 4x squared plus 83, and then plus 385. So let's see here. Now we want to factor this. And I know I'm not going to want to have 2 and 2 right here. Just a little review of factoring. I know I can't use 2 and 2 because that means when I multiply my outside and I multiply my inside, then I'm going to end up with an even number and an even number, but they have to add together to give an 83. I forgot my x, an 83x. So since I know that they're going to add to an odd, I can't make sure that I have an even and an even. So I can't use 2x and 2x's, and I'd have two evens, and I can't get an odd that way. So I'm going to have to use 4x and x. Now this one is kind of a big booger, but we can see something cool here. See, 3 and 5, if you add them together, then you get that middle term, which is an 8. So that means that it's some sort of multiple of 11. Whenever you have a 3-digit number and the two outside numbers add to give the middle one, it's some sort of multiple of 11. So let's see here. We know it's a multiple of 5, so this would be 5 times 7 times 11. Okay, now let's try something here. Let's put a 7 in right there. That means that my other terms would be 55. I think that'll give me what I need. Now I have a plus and a plus. Since this is a positive, I know I have two of the same thing. And because this is a positive, I know that I have at least one positive. If they're the same and one of them's positive, well, I have two positives. So let's just check it out to make sure. I multiply these and I get a 28x. I multiply these and I get a 55x. Add them up and you get an 83x. That's good. So that means that we picked the right factors. Now I need to set each of these equal to 0. If this one's equal to 0, I get negative 55 over 4, and the other one is negative 7. Now, they didn't have us do any homework with the domain restrictions in the radicals union, but we know that we're not allowed to have a negative under a radical. That's going to cause some problems, because if one of these answers should have produced a negative, we would have squared it out. When you square that negative, it's going to turn it into a positive. So possibly one of these will not work. Let's try it out. And through the magic of technology, here is all the arithmetic worked out for you in the check. So if you plug in the negative 55 over 4, then you end up with an 11 over 5 is equal to a negative 11 over 5. Why don't you try that in a calculator and make sure that you're hitting all the right buttons and getting to the same place I am. Now, this is not true. 11 over 5 is not equal to negative 11 over 5, which means that when we checked it, we got a false. That is, so this negative 55 over 4 is not good. Now, then we checked the negative 7. You plug it in here, and you get a negative 35 plus 99. That's a 64 under the square root. Over here, you get a negative 14 plus 22. You end up with the square root of 64 is equal to 8. And yes, in fact, the square root of 64 is 8. What this tells us is that we got two solutions, but only one of them worked. The reason why goes back to the idea of domain restrictions, but we are taught to check these radicals. The only solution is negative 7. This is my homework problem number 20. Now I have two radicals here, but our goal is to isolate a radical before we get started. So I'm going to add this radical to the other side. It's going to move as a whole unit because it's under that grouping symbol of a radical. So 4y plus 20 is equal to the square root of y minus 4 plus 6. Now I'm going to do the same thing that I did before, which is square both sides to get rid of this radical. But remember that this thing is moving as a unit. So I get 4y plus 20 is equal to, now when we square something that's kind of like a binomial, this is going to be our first term and this is going to be our second one. Remember that it's the first thing squared, so I get y minus 4. At the end, it's the last thing squared, so plus 36, and then double their product. Well, that's 6 times the radical, so I'm going to end up with plus 12 times the radical, y minus 4. Now, I have this radical. I need to isolate the radical. So I'm going to move things over to this side. A negative 4 and a 36 make a 32. So I'm going to subtract 32 from both sides, which will get rid of those. And then I also have a y that I'm going to subtract from here. So 3y minus 12 is equal to 12 square roots of y minus 4. Now I could divide everything by 12. I'm going to have a fraction there. I'd like to divide everything by a 3 instead. I'm not going to get rid of all of my numbers, but I can avoid a little bit of the fraction work. So if I divide everything by 3, then I have y minus 4 is equal to 4 square roots of y minus 4. Since we divided the 12 by 3, then that counts for this whole right-hand side. Now, this is close enough to isolating a radical because I don't have any pluses or minuses or anything over here outside my radical, so I can square both sides. So squaring this, I'm gonna get a perfect square trinomial. So y squared, and at the end is plus 16, and in the middle is double their product, minus 8y. And that's equal to 16 times y minus 4, because I squared the 4 and I squared the radical, which made the radical disappear. So this is 16y minus 64. And I'm going to move everything over here because I have a quadratic. Since I have a quadratic, that means I need to set it equal to 0. So y squared, and then if I subtract 16 from both sides, I get negative 24y. And then I'm going to add 16 to both sides. Or sorry, I'm going to add 64 to both sides. And so not only here, but also here, and I'm going to end up with plus 80 is equal to 0. And now I need to factor. Magic arithmetic. Feel free to pause, but I factored by setting each one equal to 0, checked them here, and they both work, so both are solutions. Now let's talk about how to solve equations that are of a quadratic form. They're going to remind us of quadratic equations. They're not quite quadratic, like this one's quartic because it has a little 4 right there. So also notice how this is a constant term, which means we can't factor something out. Sometimes we've been given something where we have something that's quartic and something that's cubic and then something that's quadratic, and then we can factor out x squared. But we can't do that here because there's no x's to factor out of this one. So, but the thing is that we do have a pattern. That 4 is double that exponent, and that's a constant term. So it's not this problem, but it reminds us of this one. It reminds us of x squared minus 8x minus 20 equals 0. It reminds us of that idea. It's a lot like it because that exponent is double that exponent, and just like that exponent is double that exponent. And what did we do here when we set up these things? And whatever our middle thing was, that's what goes in that first spot. So same idea. Now we have minus 10 and plus 2. And we're going to work from there. Now, going back to this idea, notice how my thing in the middle, that's what goes in the first spot of my set of parentheses. Well, again, that's what's going to go in my first spot in my set of parentheses. When I factor this, instead of saying x, I'm going to say my middle thing, x squared. X squared minus 10 and x squared plus 2 equals 0. Now this thing is factored, but I need to work on it a little bit more. So if x squared minus 10 is equal to 0, then x squared is equal to 10. So that means that x is equal to plus or minus the square root of 10. Over here, if x squared plus 2 equals 0, then x squared is equal to negative 2, which means that x is equal to plus or minus I square roots of 2. So when you type this answer in, you're going to have 4 answers. You have the square root of 10, negative square root of 10, and then I square roots of 2, and negative I square roots of 2. So we have 1, 2, 3, 4 answers. And we know that we're supposed to be looking for 4 answers because this is a 4th degree. So one other thing though, when you see something that's of a quadratic form and it just drives you nuts to try to put an x squared in this spot, you don't want to see something quadratic in that spot, we can do what's called a u substitution. That means call u whatever the middle thing is, x squared, and then you can say that that means the same thing as u squared minus 8u minus 20 equals 0, and then you can factor with u's. So u minus 10, u plus 2, and then that means that u is equal to 10 and u is equal to negative 2, and then once you have these solved for u, then you can put u x squared back in for u, and then finish the problem from there. You'll get back to these answers. So the idea is that the middle thing, the middle kind of term, is what goes in the first blanks. And if you don't like that one, then you can change it to a u and then switch it back at the end. Now let's look at our very last problem of a quadratic form. Now, I say that it's a quadratic form. This one looks kind of funky, but don't worry about it because we're just looking to see if this exponent, and we have all the same junk inside of here. We have the x plus 2 and the x plus 2 again over here. But this exponent is double that exponent. This would be an excellent place to use a u substitution. I think we're going to do it that way first to show you what I mean. In this case, u would be, and then you just pick the middle thing. The middle thing would be x plus 2 raised to the 1/5 power. That means that you have u squared, that exponent goes there, minus 6u plus 8 equals 0. So I made this crazy thing something more reasonable. We called it u. And then we can factor this. This one's easy to factor. So then I have u minus 4 and then u minus 2, and that's equal to 8. So that means that u is equal to 4 or u equals 2. It's not equal to 8, it's equal to 0. So now that we have these two things, we can go back and put this in its spot. So we have x plus 2 to the 1/5 power is equal to 4, and x plus 2 to the 1/5 power is equal to 2. So if we have something raised to the 1/5 power, then what we need to do is take that and raise it to the 5th power to make that go away, to turn that into an exponent of 1, which means we need to balance it by doing this. So we have x plus 2 is equal to, let's see, 4 to the first power is 4, second power is 16, third power is 64, fourth power is 256, so the 5th power would be 1024, and that's equal to, not equal to, and then you subtract 2 from both sides, and x is equal to 1022. This one, we're going to do the same thing. We're going to raise both sides to the 5th power to make that thing go away, and then we have x plus 2 is equal to the 2 to the 5th power is 32, so subtract 2, and x is equal to 30. So we have our two answers, 30 and 1022.